Okay, just a few words on the satellite gravity and why it is important for rings. Well, I'm a geodesist, and we had, for 20 years ago, there was absolutely no useful data in Antarctica for gravity. And gravity in Antarctica is global importance. It's about the orbits of satellites and all kind of stuff. But now with the launch of GOCE, suddenly we had a full Antarctic coverage, but it's a low resolution, and actually there's nothing inside the gap at below 83 south. So we actually did, as Fausto already mentioned, the polar gap survey, which filled one void, and earlier we had some other surveys, and basically the NGG compilation, which is now 2016, is coming up shortly, filled the whole thing. And just to give you an example here, that we ran the South Pole survey, there's a post out there. This was gravity funded, but we added, of course, together with BAS, the radar, the LiDAR, the everything, magnetometer, and suddenly you get a heck of a lot of science out of somebody just funding gravity. And that's a good model, and a lot of countries were involved here for rings also. You have a main objective, but down the end you do a lot of other stuff. This is just an example of many different papers which came out from the various areas, heat flow anomalies, recovery lakes, blah, blah, blah. Very large valley going up to South Pole. That's piggyback science from this gravity survey. As Fausto mentioned, we have a new compilation under the ESA for the Antarctica project, merging everything available up to date. Mirko and company is working on the Dresden thing and improving it, especially in East Antarctica. So there's a lot of things coming in now. We have more or less a complete picture with Texas, with Lamont, everybody, and Icebridge, and everybody really did a big effort in the last 10 years. If you asked me 10 years ago, I wouldn't have believed how far we came. What can we use gravity for in rings? Well, obviously, it supplements the radar. If you have the Lambert Glacier, you have the mist picking, as we just heard from Mathieu, obviously any gravity at that area will immediately say if it's right or wrong. Gravity is also the only way to get bathymetry under the ice shelves. And we will want gravity for general geology, other sediments under the searching glaciers and so on. And we have new technology coming. The gravimeter of today is just a shoebox size, and both BAS and us are working right now to get it in drones. We have flown the first drone surveys at 1 milligal accuracy. Here's just on the bottom an example from the Slesser ice stream, Duncan's processing from our 2011 survey, and if you do a gravity inversion, you can see there's a heck of a lot of more depth down to the bottom of the ice stream there. Gravity is also useful for climate change. It's a no-brainer. You have GRACE, but you also have a lot of new gravity missions being prepared. We have the GRACE I with JPL in Germany. We have quantum methods now being prepared very early by the EU. We have Crystal, we have Sentinel-3, a lot of new satellites are coming up. All of these missions will in some way or another be using rings if we do this project. So with the rings will eventually be a big infrastructure. And just of course look at the ice velocities you can get from the different missions. Now this is an example from Envio in Austria with the flow out of Antarctica, and if you zoom into the area, as you just saw on the GOCE picture here, you have the Totten Glacier area. It's a GRACE mass anomaly. You'll also see it over there. And that's an area we really should look after. That's a high priority area maybe to start, get the missing data. If there are many missing data in that region, get that one up and really have it tied carefully with better models as Ruth presented, and get the depths and see how much we can improve by a rings-like precursor. So that's what I want to say here. It's just want to say we have the new Antarctica gravity compilation. Of course, gravity in any mission with airborne will help a lot. And we have an old geodetic dream which is fulfilled, like our global reference data, which is EGM 2008. There's absolutely no Antarctica data whatsoever in that thing. But it also shows with IceGraph what we call the first campaigns is if you don't have any money, you don't have any base. If you can find the money, you can do a lot of work at cheap rates. I mean, we didn't get funded at others, but something like half to 1 million euro or dollar per year. So, but you can still do a lot, and you do that by cooperation with a lot of different groups, doing logistics in kind, everything supported. It's probably a good way to think about rings, that you work together, many countries. You have a goal. You can generate a lot of science spin-off. The people who are interested in the science spin-off might not want to be involved in some of the primary goals, but in the end it worked really well. And just for these campaigns, these are just all the guys who got involved to get this one off the thing. So I think it's time to complete the Antarctica gravity coverage. So rings will do that on the local scale along the coast. And if we support it, I mean, we'll generate, I'm pretty sure, a lot of new science everywhere. Okay, thank you.